High performance liquid chromatography. This is similar to gas chromatography, except that it is not restricted to volatile compound. A high pressure, about 1000 to 6000 pound per square inch pump facilitate movement of the specimen through the column packed with a chromatographic absorbent, silica gel or alumina. So there will be a large pump is there, high pressure pump is there that facilitate the movement of the specimen through a column. In that column there is packed with this chromatographic absorbent. What are that absorbent? Silica gel and alumina. And the effluent stream passed through a detector. Effluent stream, then this stream passed through a detector. Usually an ultraviolet, that detector is an ultraviolet spectrophotometer, and appearances of a drug in the solvent is signaled by a recorder peak in the same way as in chromatography. Again, the size of the peak is proportional to the concentration of the drug in the sample. Hplc can be used to separate and analyze the complex mixtures. Application. First is preparative Hplc. Refers to the process of isolation and the purification of that compound. Important is the degree of solute purity and throughout, which is the amount of the compound produced per unit time. This differs from analytical Hplc, where the focus is to obtain information about the sample compound. The information that can be obtained includes identification and quantification and the resolution of a compound. Chemical separation can be accomplished by using Hplc by utilizing the fact that certain compounds have a different migration rates given a particular column and a mobile phase. Thus, the chromatographer can separate compound from each other using Hplc. The extent or degree of separation is mostly determined by the choice of stationary phase and the mobile phase. Next is purification. Purification refers to the process of separating or extracting the target compound from other, possibly structurally related compound or contaminant. Each compound should have a characteristic peak under certain chromatographic condition, depending upon what needs to be separated and how closely related the samples are. The chromatographer may choose the condition such as the proper mobile phase to allow adequate separation in order to collect and extract the desired compound as it elutes from the stationary phase. The migration of the compounds and contaminants through the column needed to differ enough so that the pure desired compound can be collected or extracted without incurring any other undesired compound. Identification of compound by Hplc is a crucial part of any Hplc assay. In order to identify any compound by Hplc, a detector must be selected. Once the detector is selected and is set to optimal detection setting, a separation assay must be developed. The parameters of this assay should be such that a clean peak of the known sample is observed from the chromatograph. The identifying peak should have a reasonable retention time and should be well separated from extraneous peaks at the detection level, which the assay will be performed. To alter the retention time of a compound, several parameters can be manipulated. The first is the choice of a column, another is the choice of mobile phase, and last is the choice in flow rate. Identifying a compound by Hplc accomplished by researching the literature by trial and error. A sample of known compound must be utilized in order to assure identification of the unknown compound. Identification of compound can be assured by combining two or more detection method. Next is quantification of compound by Hplc is a process of determining the unknown concentration of a compound is known solution. It involves injecting a series of known concentration of the standard compound solution onto the Hplc for detection. The chromatograph of this known concentration will give a series of peaks that correlate to the concentration of the compound injected. Thank you.